Hello everyone, welcome to SimpliCode's YouTube channel. In today's session, we'll be discussing about web scraping using Python. Web scraping is a process of collecting and analyzing massive amounts of data from the internet. So we'll see how we use Python language in order to perform web scraping. But before we get started, consider getting subscribed to our channel to stay updated with the latest tech content and hit that bell icon to never miss a notification from SimpliCode. Without any further ado, let us dive straight into the topic.
You can actually read a little bit about it. Currently, BeautifulSoup 4 is the current version. If you don't remember the full website for it, you can always do what I do, which is go over and do a search for BeautifulSoup official site. And it almost always comes up right at the top, and you click on there and it'll take you to the crummy.com software site for BeautifulSoup. Now, we're going to use our whatever Python interface you want, IDE. I'm going to use Jupyter Lab, which is built on Jupyter Notebook through Anaconda. So when I open up my Anaconda Navigator, you'll see that I have my different tools available. Again, you might be using a different editor, and that's okay. You might be in PyCharm or something like that where you don't need to do this. And Jupyter Lab is Jupyter Notebook with added tabs and some added features. It's basically in beta testing, so it's got a few little glitches when you're saving things and moving between projects. But for the most part, it's a great upgrade to the Jupyter Notebook, and you can use them together. So you don't have to, it's built on Jupyter Notebook. So anything you do in Jupyter Notebook, you can open up in Jupyter Lab. And the first thing we need to do is we need to go ahead, in this case I'm going under my environments since it partitions the environments out, and I'm going to open up a terminal window. We have to install some packages in here to work with. Now there's a lot of choices on this. Because of the simplicity, will be using conda install. Now you can use pip install for the same thing, and we're going to install our BeautifulSoup 4. And you have to type out the whole thing, BeautifulSoup 4, and you can use a pip install if you're using a different environment. And I am using Python version 3.6, although according to BeautifulSoup they also work on 3.7 all the way from 2.7 through all of 3x. Now according to the BeautifulSoup website, the BeautifulSoup 4 works on anything, you can install on anything from Python 2.7 all the way through any of the Python 3 versions. This just happens to be Python 3.6 because there's a lot of other packages that don't work on 3.7 yet. And we'll go ahead and run this install on here and let it go through its environmental setup. And of course with conda, it goes in there and finds all the dependencies. Pip doesn't do as much as far as finding dependencies, but you know exactly what's on there with pip. So if you're doing a huge distribution, you probably want to use your pip install so you can track what's going on there. With the conda, I like to just let it take over since this isn't a major distributed package going out. Another quick note between pip and conda is that if you start on a project in one of these environments and you're using pip in there, stick with pip. If you're using conda, stick with conda. They track the packages, and you can run into some issues where they're not tracking the same packages and something gets overwritten. So it's important to stay very consistent with your install on your environments. And we'll also need to go ahead and install our NumPy environment and our pandas on here. So go ahead and do that. If you haven't added those packages in, go ahead and install those into your environment that you're working in. And of course pandas is just simply install pandas. And let's just install a couple more packages. In this case, let's get install our matplot library because we're going to plot at the end since we're going to be collecting data. And for this project, that will be all the packages we'll need. So we can go ahead and close out of our installer or whatever setup you have. And we'll go back to home and we'll just launch our Jupyter Lab, and that will open up in our browser window. Now, if you're coming from Jupyter Notebooks and first time in Lab, we can go ahead and just create our first notebook, Python 3. You can also do it under File, Launcher, and you'll see New Notebook. It automatically opens up and we can just click right on there. It'll pop open on the left, and I'll right click this and we'll rename this. We'll rename it just Beautiful. And it is a IPyNB file on there. So that should look familiar because that's a Jupyter Notebook file. This is a new one. Now I have multiple tabs, and in the past I usually hid this on the other computer, all my notes for the lesson today. But this is my notes going down, and we'll go ahead and just start going through this and see what it looks like to do a data pull from front to end and see how that works as a data scientist pulling that information in from the website. And the first thing I want to do is I want to go ahead and close this side window. That way it get the nice full screen. And we can also up the size a little bit. One of the wonderful things about working in a browser window, just do that Control Plus thing. The packages we talked about is pandas. So we imported our pandas if you haven't already. That's our data frame. If you haven't done our pandas tutorial, definitely worthy of the time time to go through there and understand pandas because it's such a powerful tool. This basically turns your data into a spreadsheet, dataframe. Our numpy is our number array, so it kind of works with pandas very closely as far as manipulating data in arrays. Matplot, we want to go ahead and bring that in, our PLT, so that we can plot the data at the end. And this line right here that says Matplot library inline is for the Jupyter Notebook specifically. It tells it to print that on this page. A lot of the newer versions don't actually require to have that line. They'll still print it on the page, but you should still include that if you're in the Jupyter Lab setup. And then we have our URL library.request. We're going to import URL open for opening up the website. And then we have our BS4, that's your BeautifulSoup 4. We're going to import BeautifulSoup. And then our last one is our RE. That is for manipulating our regular expressions. So when we get to that part of importing our data, we have to do a lot of reformatting so it's something we can use. And the RE is one of those tools. We'll go ahead and run this and just bring all that in. So this is all imported. All these packages are now into our web scraping program we're going to run. Now, if we're going to dive in and pull data, we should have a nice website to pull from. And let's go ahead and we'll use the HubberTiming.com results for the 2018 Martin Luther King race. And if we take this, you can actually just take this, where did we get this from? Well, you can go in here and find the website you're going to scrape from, and you'll see right here it says you just copy that link right in there, that HTTP. And this is the website that we're looking at, and you can see right here all the information that we're looking at. Let's say we wanted to run some statistics on this. It sure would be nice to be able to pull it off of here. And if they don't have a direct API, that means we need to pull it from their website. Some of these will have a download, although if you've ever done it where you have a download click and maybe you're paging through 100 websites, in one case I was pulling all the different United States bills that are passed to track who voted on them for a project. And you can imagine that there's hundreds and hundreds of those, thousands of these documents that they voted on, who voted on it. It goes through the Senate, it goes back to the Congress. So I opened up a website, pull all the links off of there that match a certain criteria, and we'll look at that in just a minute, how we go through the HTML. And then I had to reformat them, or I could hand download each one at a time, which would just be a nightmare. So it's nice to automate it. In this case, we're going to be pulling up this chart, and we want to figure out how to pull this chart off of this website. And so when we go back into our Jupyter Notebook, I've got my URL, just our name for it, and it's just a string. That's all this is. Nothing fancy there. You'll notice that on the slashes, we now have // You can do a single forward, and HTTP is a double forward. This is just how you have to switch it to match setup in there. And then it's going to go ahead and use the HTML equals URL open URL. And that's from our URL library request. So it's opening a link to that website, or at least pointing to it. And if we run this, this just sets it up. So this is all set up. And then once we've done our setup, let's go ahead and create an object called soup. This will be, and if you remember up here, here's our beautiful soup that we imported from the BS4. And this is the package that we're working with. And so we're going to do our beautiful soup on here. And on this, we need to go ahead and send it our HTML so it knows what it's opening. And then the second part is we have to tell it how the format is coming in. And the most common one for your HTML polls is an LXML setup. And so almost all of them you'll end up using the LXML. There's a few other options. And because this is so common in the newer versions, a lot of times they just leave it out just because it's already on the default. We'll go ahead and leave it in here just to remind us that it's there, and we'll go ahead and run that. And on the newer versions, they actually default it to the XML setup and the HTML. We'll just leave it out and call it HTML. So it's just going to pull from this URL. And when we run that on here, we've now created an object soup that has pulled the website into it. So soup contains the information along with information on that website and what's going on. So let's just go over what we did real quick before we start digging into the actual soup, before we start scooping out stuff. We imported our different modules that we're going to use with our package, specifically the BeautifulSoup. We did install the BeautifulSoup. If you remember correctly, you have to call it BeautifulSoup 4 specifically, so it knows what you're bringing in. And this line right here is very key. From BS4, because that's how it installs the module, we're importing our BeautifulSoup. And then we found our URL. In this case, we're going to go pull information from the Martin Luther King Dream Run. And then we set our HTML to our URL open URL. And you can see right here we imported that. So here's our URL.request, import URL open. So we're requesting a connection. And once we send that connection into the BeautifulSoup, it creates an object called soup. And then this one, of course, we chose soup just because it goes with beautiful soup. I guess we could have chosen beautiful. And now we can start extracting information from our website because we've pulled it down onto our computer under soup. And we can start by looking at the title of the website, soup.title. And if we print title.text, you'll see this a lot in Beautiful Soup because title contains all kinds of information, and if we want just the text from that title, you add the .text on the end. And you can see right here we have our 2018 MLK Dream Run 5K race results. If you look at the tab, that's the actual title up here, 2018 MLK Dream Run 5K race. That's what the title is on the website. And then you might be curious, what's in title? What's the whole title that it's storing up there? Well, let's go ahead and print it out. Here's print title and print title.text. And when we run that, you can see it has the HTML tags title on it, and then the / title to end it. And so we're really just pulling off this piece of the HTML code, and then we look at the text inside that particular part of the HTML. And earlier I mentioned links. What if you want to get all the links off this page? Well, that would be fun. We could do soup dot, and we'll do find _ put this in bracket, and then quotation marks, we'll go ahead and put A. A is the key find, and you'll start seeing a div and all the different options you have for finding these entities in a website. And then let's go ahead and just print our links, and you can see here that it now shows all the different links in here that are marked by A, because we did a find all A. And then we can also, because this is a little bit hard to pull off the H reference, so we can also add in our find all, fine tune that. In this case, the H reference equals true. We'll actually filter that out. And then finally, we might do a for link in links, and we can simply do something like this for each link. We want to actually find the H reference because we know there's an H reference in it. And if I run this, you can see it just comes through and prints them out one at a time. Some of these are really useful. So you might be looking for something that has HTTPS in it, and you know that's a link running to something else. Or you might be looking for the mail to tags, you know that's all the mail addresses. But either way, you can easily find all the links in your HTML document that you're paging through. And of course, any packages that have evolved over time, you can also do link.get hrefs, which should do the same thing as our other format. And you can see it certainly does. We get the same printout up here. In this particular case, we really want to get the data off the page. So let's go ahead and do that. Let's see what that looks like. And in data, let's call it all rows. There we go. Equals, and then we have our soup.find _ all. There's our brackets. And then if we're looking for each row in a database, you'll remember your HTML code, we're looking for the tag tr. So we want to find all tr. And we can take this, and let's go ahead and just take all our rows and do a print all rows. And about this time, you're going to guess that we're going to get a huge amount of information just dumped onto our page. And sure enough, we do. If you look at this, it just kind of goes on forever. But this is an array. Each row is considered an array. So because of that, we can do something simply as putting brackets and just print the first. Let's do the first 5 rows. So from beginning to 5. And you can see here's our first 5 rows on here. I sometimes like to just do, let's just do row 0. And we see that row 0 is finishers. Finishers 191. And just out of curiosity, if that's 0, what's row 1? Mail. Okay, so we're starting to see titles going across here. So if we come up here and we do rows, we did what, up to 10? Let's just take a look and see what 10 does again. And just take a look at that information that comes across. Place, bib, name, gender, age, city, state, chip paste, gender, and so on. So it comes all the way down here. We kind of have an ending right here, and then we have 1, and then we actually, it looks like we start to have information. So we have our 1, our 1191, Max Randolph, that must be the name, Mel 29, and so on. You can start seeing how the information starts getting displayed going down. So the next thing we want to do with this, and I'll go back up here and just edit the space we're in so it starts to make a little bit more sense. Keep it all together. And so we want to do for each row in all rows, we're looking at, what information are we looking at? Well, we have our TH up here, that's the header, our TD down here, which looks like the individual information. And we really are looking for the actual data. So we're looking for our TD tags in the rows. And we can do that because remember when it stores the row, it also stores the tags underneath that. So all rows have all the different tags in it. And you can see right here as you print each one of those out. And so when we look at each row, we can create another variable and we'll call it row list. and we'll set this equal to, in this case, row, because we've already pulled all the rows out of soup. So now we want to find for each row, and in there we want to find our TD. And if we go ahead and just print, I'm going to do it, if you notice I changed the indent, so I'm just going to print row list. What this does is the last value to go into row list, our last row is going to print now. And of course make sure you have an underscore instead of a period when you're typing. So row.find underscore all TD, and if we print the last row, you can see I have all the data coming across here. We have our 191, our 1216, Zuma, Ochoa, I hope I said that right, female, I believe that's age 40, and so on. And then we can take our row list, and there's a lot of things we can do with the row list. But we'll do let's do object, or let's just do cell in row list. And so we're going to look at each cell, because this is, if you look at this, they have commas separated between the different objects. And then we're going to go ahead and print cell.text. Let's just take a look and see what that looks like. And we can see here for each row we get 191, there's our 191, there's our 1216, 1216, our individual who's in the race, and so forth all the way down for those different settings. And let's go ahead and create a new variable up here. We'll call this all, let's just call it data. We'll keep it simple. So here's our data, and then we have our row. We take our row and we break it up into individual cells. So we'll call this data row, and we'll set this empty to an empty row. And we're going to take our cells, tab this, and we know that each cell generates a text. And so what we want to do is I want to take my data row, let's just replace that, and let's take our data row and let's append our cell.text. So I'm going to add each row is going to be a row of the different text on here. And then once I create each row, I want my data, which is going to be everything, to append each row. And here's our data row. And then if we go ahead and come down here, and let's just print data. Now, if we were working with large data, we'd be very careful about just throwing all our data on the page. But you can see here, we throw the data on the page and we get finishers, 199, male, 78, female, 113, 1, and so on. And if you look at this, this is the headers on the file. We have finishers, male, female, it's just like some general statistics on the first one. And then we have actually an empty data set, and then we have our data that continues, which the actual information we're looking for. So we have 1, 1191, Max Randolph, male, 29, Washington, D.C., runtime, 1 of 78, and so on here. So we could really quickly get rid of that. A number of different ways to do that. One of them is just to do, we're going to set, if we do data 2 on, we should get rid of everything, but we want to keep Randolph, so make sure Randolph is in there. Oh, we lost Randolph. Let's try 1 on. There we go. There's Max Randolph on there. So we can just simply redo our data on here, and we can do data. Probably want to do it in all rows from 1 on, but I'm just going to do my data equals data 1 on down here. There's reasons to split it this way. In data science, sometimes you don't want to touch the original data in case you need it, in case we do need the first row. So we'll put it down here, and maybe we'll just call this titles. Titles equals data of 0. And so we could do something here where we print, and we'll print up our titles, and we'll print our data. In this case, instead of 1 on, let's go -2. Let's look at the last 2 rows of data. So here we have our titles, and for some reason just put in finishers of 191. I was expecting a little bit more up there. And we have our last couple people, and they look like the data on these looks just fine on here. Turns out this is just some generic statistics up here. So we'll get rid of titles completely. It doesn't really do us any good. But we know that data comes in here, and we can look at our data and look at the very end of the data too, the -2 to the end. And we can see it pulls the data in pretty good. We don't have anything too funky in here we're looking at. It looks pretty clean. Now you got to be a little careful, because at some point we might have to come back here and clean up the data if we get an error for running data analysis. We might find out there's some unusual characters or something is misset in the data itself. And you also notice that everything is a string. So when we're bringing it in, we might have to do some conversions to test it out and convert them to whatever kind of data format we're working with. So at this time, we want to go ahead and bring in our pandas. And let's go ahead and call this df for data frame. We'll set it equal to, and if you remember correctly, we imported pandas as PD, and that's standard. You'll see that in most code examples where they import pandas as PD, and it is capital D, capital F for data frame. And we're just going to bring in our data. That's what we called it on here. And let's take this and we'll print. Now when you're working with data frames, you're usually talking large amounts of data. And so you almost never want to print the whole data frame out. We're going to go ahead and do that anyway, just so we can see what that looks like. And you can see in here, brings in our data frame coming in here. We just have a mess of information. This is our data. Let's go ahead and print df and see what that looks like in the data frame. And this is nice because it organizes it into a very easy to read table. And we have, they set the label 0, 1, 2, 3, 4, 5, 6, and so on. And then we have each row. We have Mel, 78, none, 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 none. Going across, when we get all the way down here, we'll see Max Randall, about number 3. And the first thing this does is this flags me that I brought in a bunch of information up here that we really didn't want. It's from 3 on that we want. And we can clean this up in one of 2 ways. We can try to clean it up under the data, or we can clean it up under the data frame, depending on what it is we're trying to do. And so to fix this, I want to go ahead and just change it up here in the actual data pull in. We don't need that information. So I'll rerun it, reload our data from 4 on. And then when I run this, we see we have Max Randolph is right at the top of the list like he should be, and we have all the data going down. Now with the data frame, remember I said we don't usually print the whole data frame. We'll go ahead and do df.head. And this prints the first 5 rows. And you can see that we have 13 columns. Here's Max Randall all the way to Theo Kinman. And I usually also print df tell. And the reason I like to do these particular 2 setups, and I'm going to change it just to 2 rows, because you can do that, you can print as many rows as you want, is it's good to look at the first part and the end, because those are usually where you have extra data brought in, something's messed up. And you can also see that we have 190 rows in here. And it comes in with our Zulma, Lisha, and they're both on here on the list. So now we have a nice data frame, columns and rows. We can easily look at it, we can see the setup on here, and we can look at the names and everything. Now at some point you might be looking at these individual columns and find different information that needs to be re-edited. If you can, you try to do it with the whole column under pandas. You can, up in the upper part of the code where you went from cell to cell or row to row, you can look at individual cells, maybe find a marker in that cell that's something specific, like remove all colons or semicolons or something in there, or brackets. So there's a lot of options in there. But you'll find that this one actually comes in pretty clean on here all the way down. And the next thing we really want to do is we want to look at the headers. I don't know about you, but it doesn't make any sense to me when I have column 1, I don't know what 1191 is or 1080, need name Kaiser runner. I'm guessing that's column 2 is names. Third one, it looks like male or female, probably age, but I don't want to guess. I want this to bring in my column so I know exactly what I'm looking at. So how can we make BeautifulSoup do that for us? Well, let's take our column headers. We're going to set that equal to our soup find underscore all, and then we're going to look for our headers, our th files. And since we're in Jupyter Lab, in this case Jupyter Notebook, I can just type out column headers. If it's the last variable I have listed, it will automatically print it. So it's kind of a shorthand. And we can see right here we have place, I'm guessing that's bib, name, gender, age, city, state, chip time, chip pace, and so on. So we have all our headers right there. I shouldn't have to type them all in. And we'll go ahead and do it before. We'll go ahead and do a header list equals our empty array. And then we can do for column in column headers, and we can take our header list and just append. And what do we want? We want the text from the column, so we'll just do column.text. And then if we come down here and we print our header list, let's see what that looks like. If we did it right, we should get a nice list of all the different column headings we want. So we have place, bib, name, and so on. And then pandas, just because pandas is so cool, we can simply do df columns equals our header from our header list. We can simply set df columns set to df headers, and then if I print df.head, we'll take a look at that, and we'll see right here it has nicely placed our values on here. Place, bib, name, gender, age, and so on. So very quickly we've created this nice data frame. We have the data displayed in nice rows and columns and easy to read. And then as a data scientist, the first thing we want to know is the info. What is in these columns and rows and headers? And you see right here they all come up with non-null object. There's a big flag. So if I want to do anything with this, these are all coming through as strings or an object. I usually mean strings in this case, that they're a string variable. And we have, you can quickly read through this, 191 entries, date columns, total 14 columns. There's a total of 14 columns in the data, and it shows you all the different names and what type of column they are. And it's probably good also to look at the shape of the data. df.shape, we'll go ahead and just run that. You can see it's 191 by 14, 14 columns, 191 entries. This is more like the way you look at a NumPy array, 191 by 14 for the shape. And remember, this is a variable, so if I put it on, if it's a last variable or last value in the set of cells, Jupyter automatically prints it out. So if you're in a different IDE, you'd want to go ahead and use the print statement on here. And then one of the things you'd want to also go through, we'll create a second one, df2 equals df.dropNA. Now the axes is automatically equal to 0. So a lot of times you'll see something like axes equals 0, comma, how equals any. Axes equals 0 is default. That means we're looking at going down the rows. You could look at the column going across. Let's remove the how any because that's just going to confuse you. The axes is whether you're going down the columns or if you're looking at it row by row by row by row. Or you could be looking at it by column by column by column. This would drop any column and it would drop off the NA in any column. And how equals, and we want any. I always confuse all and any because they both start with A. All means that all of them have to be non-value, where any means that any of them can be there to drop it. So this would drop any column with a null value in it. But we want 0, and it'll drop any value with a null value. And then because 0 is always the default, we'll just leave it out. And then it's curious as to what the shape is now. Did we lose anything? Was there any null values in our df2 that we dropped from the df? And we'll go ahead and run that. And we see 191 and 14. So we didn't really drop anything. But it's always good to check. There's other ways you can also do, are there, let's see, any NAs? You can detect NAs in here. Null values, infinite values. That's another one you got to watch out for. We're working with data that we're going to do something with here in a minute. So you got to be a little careful also in the conversions. Are you going to convert something where people typed in weird characters to describe the data a certain way? So now we've got to this point where we have all our different columns, we have our different data, and at this point maybe you're asking, or maybe the shareholder of the company is asking, hey, can we look at the, based on the chip time, here's our chip time, can we plot that versus gender? How does gender versus chip time compare? And so we can do that. We can take that. And the first thing we look at is we say, hey, well, chip time came in as a string, and that's going to be an issue. Now, there's a number of ways you can change this. One of them is we could go all the way back up here where we created the data and find a way to tag it and say, hey, whenever this cell text, maybe instead of appending this, I noticed that anytime there's 2 colons in it, that's probably a time signature. And let's convert all the time signatures to date time filled or whatever. A lot of times you don't get that. You don't get that option. And that's always a question in bringing in data. Whether you convert the data coming in at the beginning, or do you wait till you have it, open it up, and then convert it when you go to use it. We're going to go ahead and convert it after we got it into our data frame. So we have our df2 here. We've dropped all of our NAs. We have a shape. In fact, let's do this since there's no difference between df and df2. Well, we'll just go ahead and use df2. So let's go ahead and take our df2, and we want to take that specific field and convert it into some kind of numerical value we can use. And let's add another column. A lot of times this is something you want to do is where you want to go ahead and keep all the original columns and just add a new column in there. And this new column is going to be based on the, if we remember correctly, we had chip time. That's what we're going to look at. Okay, we want chip time versus gender. If we go into our pandas, we find out we have pandas to delta, and this is actually time delta. And then we just want to take our df2, and we're going to use the chip time column. So this is going to say, hey, let's look at, let's convert everything in df2 chip time into a time delta format. That's the data type we're going to put it as. And we can go ahead and just run this. And if we go in here and we do info, df2, and we'll keep our, we're going to look at this particular column, but we want to keep it as a data frame. So this is a list of all the columns we want to look at. We'll just do .info on here and run that. And we do an info on that, you can see it's now a time delta 64 nanoseconds. Well, we really don't want nanoseconds. We actually probably want to do it in minutes. So let's take a look at that, and let's take this whole thing, df2, let's just set the df2. We have our df2, this is a column we're working with here, and we can use the as type property in pandas. And so we can set this equal to df2. We'll take our same column in here, and we'll set it as type time delta second. So it's still a delta time here. So if I run this, you'll see that it still comes up as, where is it? Oh, it turns it into a float. So we're now at a float 64, so it's the number of seconds in that delta time. And then finally, we want to go ahead and turn that from seconds to, say, minutes. And you know, there's 60 seconds in minutes, and so now we divide by 60, we still have a float. We have our info that shows us it's a float, and then we can go ahead and just do a print df2, and let's just keep it small. We don't want to look at all our data. We just want to do the head of it. And we run this, and you can see right here where we go to, it'll be the last one. Here's our chip time in minutes. And a lot of times, just to make life easy for viewing, since we're only looking at this particular element, we can do chip time in minutes, and now we just see that, oops, we take off. We'll go ahead and take off our info. Done with that, and we'll run this. And you can see we have our minutes, 16.8 minutes, 17.51 minutes, and so on. It's a float number. Now keep in mind, this is 0.8. That's not 16 minutes and 80 seconds. That can always throw you if you're going through so many numbers you forget. So important to remember that. And we're also going to look at, the other one we're looking at is what? Gender. We want to look at gender to chip time in minutes. And so we can see here under the head we get male, 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 and a number of different setups. And let's switch this to tail real quick and just look at the end of it. And here we have female, female, male, female, female. So we have two different genders, and we have our chip time in minutes. And if you remember, we brought in our PLT. If you haven't used the plot library, the matplot library, you have a drawing place you're putting stuff on. So we have our PLT, we're going to do a bar graph, and we just want to simply use our df2 gender and df2 chip time in minutes. So that's going to plot the two bars. And to make it pretty, we'll go ahead and give it the X label gender, the Y label chip time minutes. And that simply is, remember, it always plots X and it plots Y. We have our gender, our chip time. Give it a nice title, comparison of average minutes run by male and female. And if we go ahead and run this with the correct titles in here and everything matches, you'll get a nice graph. We can see here the comparison of average minutes run by male and female. Here's our chip time in minutes. The men seem to be slackers in this particular case. And it's actually, there's a number of studies that show that women tend to have, as far as doing cross-country, there's a lot of women who have a longer endurance than men. So it's not too surprising. But we can see here the average chip time around 70, and for women over 100 minutes. And then another really cool thing we can do is we can describe the data. So df2.describe, this again is a pandas function, just like info is. And we're going to include np number, the numpy number. And if we run that, you'll see here it comes up and it says chip time in minutes, count, it gives you the average or the mean, standard deviation, the minimum, the maximum, all the different descriptive information you're going to want from your data set on there. And just because there's all kinds of fun ways, let's do a box plot to display your information. We can do a box plot where the column equals chip time in minutes. And let's go ahead and run that. Keep mistyping my chip time in minutes. And you can see it puts out a nice box plot showing you the information. We have our different values and floaters. And this is always interesting because this is a nice way of seeing where we have these floaters, one up here and there's two up above, and of course your nice spread on the box plot. And we can also modify this a little bit, and we can add in by equals gender, and then we'll just give it a blank title. I don't know why we're giving it a blank title. We'll just add a Y plot, Y label on there for runtime. And if we run this, you can see here box plot grouped by gender, chip time in minutes, and now we have our female and male, two different areas, and you can see how they vary. You have your two different your outlier up here, and you can also see how there's such an overlap between the two different values. So if I was looking at this, I'd be like, wow, I really could not draw a conclusive thing on this saying that women's runtime was more in general because they overlap too much. That would be one of the conclusions I'd have to come up with on here. And then we get to maybe the partners come in from the company and say, hey, we'd like to know the age versus chip time in minutes. That'd be something worth knowing on the statistics on this. And the first thought is we can simply plot it. And we can do this. We can actually plot the scatter plot chip time versus df2 of age. There's our XY coordinates. But if you remember from DF2 when we did the info, let's go way back up here. We're looking at a data object as far as our chip time on this and our age. Now we converted the chip time, but we also need to convert the age. And if we do it right here, we just plot it, and it'll actually let us plot it. It shouldn't. It should give us an error, but it does let us plot it. You'll see the ages come up a mess over here because they're converting it to weird float numbers and all kinds of things. So what we want to do is we want to take our age, and we'll just call this age underscore I. So we're going to take our age and we're going to create another column for DF2, age underscore I. And the I is just going to stand for integer. It's our own choice of values. There is a number of ways to do this, but we're going to do pandas to numeric is the best way in pandas. And the reason we're doing this is that numeric creates a float value. So right off the bat, we want all our stuff converted. It converts it to the least common denominator. So if they're all integers already, you'll get integers. As you can see from here, it's doing some kind of conversion that converts it to a float value. The other thing that numeric does is if there's a null value or they put in like a blank line or a dash to represent no information, it'll convert it to a null. So it goes from like a string to a null versus just having some kind of made up number that Python somehow created for the graph we have below. And then we want to add our df2 age because that's what we're converting to numeric, and then we want to coerce it. And there's a couple different options on this, like you can have it where it just doesn't process it in pandas, but coerce means that if it gets a weird value, that is a null value now. And since we're dealing with errors, this is what happens when you get an error converting it. We want to coerce it. There we go, and put the end bracket on there. And then finally we want to go ahead and round this off. So we'll put brackets around all the way around it, and this rounds off everything in this series. So what we've done here is I've taken df2 age, which is a D-type object, which in this case is mostly strings with a couple of blank ones in there, and we're going to convert it to a numeric, which will automatically go to float, and then we're going to take wherever there's an error, wherever it says, hey, this doesn't convert, and usually that's a blank string. Like I said, I've worked with so many databases where someone puts down none, someone types in space, some types in a dash to mean none, and you get this really weird conversion coming up. This covers all of that in pandas, so it's really a nice way of just coercing it and saying, hey, if we don't have a number in there, let's make it a null value, and then we're going to round it off. And then finally, let's go ahead and take our df2. Here's our df2, and let's drop those null values. Drop NA, and we want how equals any. So that means if there's any null values in the data set, now this might get you in trouble because you might have null values in a different column, and so you might lose data that way. At this point, we could also do like certain parts of like drop just certain columns with null values. There's all kinds of other options in here, but we're just going to do we're going to just drop any, and we want to do it in line equals true. So that means it's going to reassign it to df2. So df2 now has rounded out, so it's rounded to the integer. We didn't do any places. The age, and it's going to be age I, and then we've dropped all our null values. That way we're not going to get any errors when we try to plot a null value. And it also makes sure that data, by deleting out the rows, because that's what this does, it automatically does axis 0, which is your rows, axis 1 is your columns. By doing this, it automatically removes all the rows with null values. So it just cleans out the rows. And then when we go ahead and plot this, we see we have a nice clean data, and we have age all the way up to 70. So we have our chip time set, and then our age going across, and it makes a nice plot that you can easily show for display and for and you can easily show that to your shareholders or whatever group you're working on. It makes a really nice and quick, easy display.
With that, we have come to an end of the session on web scraping using Python. I hope you've got an idea of what web scraping is and how we use Python language to perform it. Thank you for watching the video. If you have any queries regarding any of the topics covered in the session, let us know in the comment section below, and our team will resolve and help with all your queries at the earliest. Until next time, thank you, stay safe, and keep coding.